This differential equation over here that says x squared times the derivative of y plus xy will equal 1. In order to verify that this is a solution, what you've got to do is take the derivative, substitute it in there, take the original function, substitute it in there, and then do the algebra and show that it will equal a 1. So we need the derivative. This is going to require the quotient rule. Start with the derivative on the top, which would be 1 over x plus 1 times the bottom function left alone minus the derivative of the bottom function and then the natural log left alone. And I probably should do some algebra to clean up this complex fraction, so multiply by the least common denominator, which is this x plus 1. And multiply all three terms by it. So the first term would just become this x, and then minus, I would put the x plus 1, this red x plus 1, in front of the natural log. And then it's all divided by x squared times x plus 1. Okay, so we're going to substitute that fraction in for y prime. Take the original function, which is y, and substitute it in for that y right there. And then do the algebra, and supposedly everything's going to cancel and just leave us a 1. That's going to be interesting. Let's see. So x squared gets multiplied with the y prime, so that's this guy. And then x gets multiplied with the original function. And then supposedly all of this is going to cancel and just leave us the number 1. Well, let's see. We can have x squared cancel x squared, and we can have an x cancel an x. And this has natural log of the x plus 1, so does this, but right now it's tied up with this x plus 1. So I'm going to go ahead and distribute this natural log and distribute the negative. So you had to have x minus x times the natural log, and then minus times the 1 times the natural log, so minus the natural log of x plus 1. And then plus over here, we would have natural log of x plus 1. And then we've got a couple of things canceling. And we're left with x minus x natural log of x plus 1. Nothing else can cancel. You could factor out an x, but it's not going to cancel. Over here, we were promised that everything was going to cancel and just leave a 1. It's not true. That doesn't equal 1. And so verify is another way to say, is it true or false that this is a solution to this differential equation? And in this case, it turns out to be false.